guys, a very happy morning to all of you, and now we are just going to see the next lecture in the mechanics, means manufacturing technology, the third lesson. So in the previous class I just explained about what is the sand casting and how the sand casting is a little bit different. So I would have explained about you in each and every in a very detailed way. Okay, so in this thing, after just having a 5 minutes of revision, we can just go directly into the next lecture. So because I just told you about what is sand casting and how the sand casting is varying, and the pattern must be removed before the sporting the mold, each and everything I just told, and what is screw I also just told to you, and sequence steps of making the sand casting I just told to you, and cope drag and how the cope will be, how the drag will be, and how the cheek will be, the intermediate molding glass on 3 pieces I just told about it. And later on I just explained about the pouring basin and how the runner will be, as well as it means the pouring cup, the screw will be, as well as the in-gate area and how the screw area will be on the runner, as well as the in-gate area, it means the entering part of each and everything. And the riser reserve, and as well as I just told about the yielding, it means how much the percentage of yielding will be volume of the cast divided by volume of cast plus of volume of the entire remaining of the gating system. And I just told you about the thing. Okay, the next thing is flask mold I just told you, and runner pouring machine and baking sand I just told, and molding sand I just told you, and the thing vertical chamber through which molten metal flows downwards from pouring up to the runner is a wood screw. Okay, so chapter I just told you why chapter is important to support the core and why the chills is important. It's like to provide the external solidification, it means quicker. So to increase the cooling rate of the casting, so that for riser I just told you what it's just a reservoir, or sometimes the core pins may be shifted. So that we just use the core. Next one is padding. Padding is a uniform solidification. That's it. So it's like a thinner section towards a thicker section. It's known as padding towards this extra material required. So why this thing? It means I just told you each and every. The main purpose of the glass is to provide to support the core. So which are the following is this one I just told you. Green sand means resistance of moisture. And I think so I just told about the, it means pattern is pattern also there are little bit of allowance. One is shrinkage allowance or contraction allowance, distortion allowance, and it means draft or tapper allowance, misting allowance, and distortion or camper allowance, and wrapping allowance I just told you. So in the pattern allowance it means this cases solidification shrinkage, it means there is shrinkage. One is the liquid shrinkage and solidification shrinkage, as well as the solid shrinkage. So liquid and the solidification shrinkage is being compensated by the mixer, but the solid shrinkage is being compensated by the which one? By the pattern. Okay, pattern. So liquid shrinkage because each and everything will reduce. You can see each and everything will be reduced. So solidification I just told you, and in this thing you can see the gray casting increases, this expands on the solidification, especially in the solid shrinkage. In the liquid and solidification it may shrink, but when it reaches to solid shrinkage it will definitely try to expand. So for the pattern only is material. And the pattern allowance, it means you can see which one has so much amount of pattern allowance is carbon steel. Carbon steel need a lot of pattern allowance. Okay, so the next thing is again white cast iron also, and zinc also has 25 mm of mercury, and I think so you are getting a point. So all metals shrinkage and liquid shrinkage, but cast iron, it means especially it increases during the solidification shrinkage. And you can see double shrinkage allowance is provided on the pattern dimension. It is used for the casting of the metallic pattern, which would ultimately be used for molding to take care with this one. Okay, so which one large size of riser? Riser is in. So riser means you can see this one especially. So you can see aluminum has 6.6, solidification need riser. Aluminum 6.6, and copper, magnesium, zinc is in it will be 4 to 5. 4 to 3. Okay, okay. So next thing, it means which one the following requires largest shrinkage allowances. You can see plain carbon steel, literally 21 mm per meter. So aluminum is 13, brass is 30 to 16, and the cast iron is a little bit lesser. Okay, so next one, this one. Okay, this additive metal, metal I just told you, it is copper, zinc, and as well as tin. And I just told you why this kind of metal is being used. Solidification is okay. This one shrinkage allowance is made by adding external as well as the internal dimensions. Okay, this one I just told, this one. Okay, volume of patterns. Okay, this one I just explained, this one. Okay, and this one I just told. So it means just step by step we need to go. Okay, it means for the first step you can see 50 mm, it means 50 mm the whole cube into, it means 4%. You have to just multiply, and you have to minus all the entire thing. Okay, by the step by step we need to go. Okay, I think so you are getting the point. So okay, so next one is more, and I just told about what is draft allowance. We just push a little bit outside, so we do take the each and everything, it means easier. So So shake allowance I just told, and the distortion allowance I just told. So how the distortion allowance is given? Because of the generally lesser weaker section, we need this kind of distortion allowance we generally place it. Okay. So the next is distortion allowance. I just told you, since it is weak, we need to follow this kind of extra material. We need so pattern material. I just told you about wood and what other thing. A metallic pattern also more expensive, but they are so much stable, and the white metal is always mercury is not being used. And sometimes you can see the it means plastic material also being used in full mold casting. Expanded polystyrene is used. Investment casting uses wax pattern. Each and everything I just explained. So pattern is just a normal thing. So resistor to corrosion and so chemicals and dimension stable. I will bet low cost this one I think so. And easily obtain light to everything. This full pattern is made of generally which one polystyrene. Okay. So this one pattern is normal thing. It's not anything that much. So this is the cooling curve. You can see this is the pouring temperature, and this is the liquidus, and this is the solidification. This is solid. Okay, because your time is also dependent. Okay, we should depend on the time. We should tell about that. So fluid rate is told and pouring temperature is told, and the excess pouring temperature affects why the core is used and how much the thermal salt is. So there will be, it means the baking sand is there, and also core sand is also there. So we need to see about all the things. So green sand, dry sand, refractiveness. So refractiveness means the core should have a good amount of strength to withstand the excess of temperature. That's called as refractiveness. So permeability means the gas should go out there, you can use the easier way. So next one, permeability number is 501.28 divided by P into T. Okay, 501.28 into divided by P into T. So this P is pressure in gram per centimeter square, and T is in time, it means minute. Okay, do not get confused. Okay, next one, suppose if P, it means a permeability number equal to VH divided by PAT, PH divided by PAT. So next thing I just told about collapsibility. Best definitely the collapsibility of moldings, and also the core sand should be, if it's not been released from a lot of problem, especially for hot air. And friability means I just told you what is mean of friability. So the ability to crumble should be very important and the considered time. It means how much easily we can just take the core outside. Okay, that's the thing called friability. Smoothness, no emission I just told you, and the core sand I think so you don't know. And that by suppose means density. It means especially the total volume into gravity of density of the mold minus density of the sand. Okay, so density of the liquid metal minus of the weight of the core displaced, weight of the density of the core. Okay, I think you are getting a point. So we need to implement this net by is so much important. And carbon dioxide molding, I just told the carbon dioxide is used as a binder, and this is a quick process of core or mold evaporation. So this mold is evaporated with a mixture of sodium silicate and sand, and it is carbon dioxide, and now definitely the dry compression rate of nearly 1.4 megapascal has been achieved. So next is carbon dioxide. This one is the same. So it is quickly, it will be so much quicker. So next one I just told about moldings and property, porosity, permeability, strength should be, and as the temperature of it means as you just add water, how much each and every behavior will change. I just told to you, and refractance, plasticity I just told to you, and grain number is n equal to 2 n minus 1. So ns, it means capital N is within 100x, it means within a square cube of 100x of zoom, how much particle is being present at that's it. So small n is that's it means grain size number. Okay, grain size number, that's it, grain size number. Okay, do not be confused. Grains and the mold contains moisture is termed as grains. Okay, that's it. This one. Okay, so it's volume of casting will be volume of casting will be volume of getting. Okay, so getting area I just told. So runner should be, most of the things should be trapezoidal. So if runner is in horizontal means it's good, but it will lead to a problem. Okay, next one, choke area I just told. Choke area equal to m divided by root of 2gh. This one root of 2gh into density into time into CD. Okay, just remember. So I just told about the top gate, bottom gate, and the favorable temperature, unfavorable temperature, and pressure gauge system, unpressure gauge, and all of the things I just told to explain to you before. So next one, screw design also told to you before. And how the screw design should be in the trapezoidal way. Okay, so now we can directly go for the problems. So you just take 2 minutes of time. We can go for this problem. first one, it has been asked in the 2001. Okay, so you can see the height of down sprue. So they have just given the sprue. The sprue is the height of the down sprue is just on there. So example, this is pouring cup. So this is sprue. So this is runner, and this is ingate area, and here the mold will be. Okay, it has cross section at the base. Cross section, this means so the sprue is given. Cross section is 200 mm square. So height is 175 mm, and the cross section area of the runner. So this runner area is 200 mm square. Okay, according no losses against the curvature. But even they are asking volume is 10.6 meter. They are asking only time. Time equal to how much will take. So wow. So how we can just write. So discharge equal to area into velocity. So area to velocity, okay, because here the velocity must be, and you can see this entire area. Area as well as the volume should be considered. Okay, because we need the volume, because for how much, because velocity is so much important as well as the volume. So velocity as well as the volume is so much important. So we need to calculate the velocity and how much volume, because we don't know the volume equal to 10.6 meter cube. So you can see the time is given in seconds. So what is the relation? We can just make values. So how we can just calculate? So the thing is, okay, for example, the discharge equal to what is the unit, millimeter cube divided by time. So for example, this one, if we just statement area into velocity is mm square into of velocity is millimeter per second. So the same thing you can see, this thing volume, you can just take volume divided by time. Okay, that's it, because the unit is same. Okay, the discharge q is what, use area into velocity equal to volume divided by time. Okay, since we need this both of the thing, or we need to find the discharge. Suppose if we just found the discharge, the entire diagram is open. Okay, how we can just find, because you can see the entire depend based upon this area. You can see what is the velocity. So v equal to root of 2g of h. So v equal to root of 2 into 9.81 into h is 175 mm. Point, because we will just take in the root of 2 into 9.81 into 0.175. So velocity equal to 1.85 2 meter per second. So area is 200. So this is 200 means 200 mm square. Convert into meter. So equal to 200 into 10 power minus 6, because 1 meter equal to 1000 millimeter. So 1 mm equal to 10 power minus 3 meter. So area is this much. So q equal to area into velocity 200 into 10 power minus 6 into 1.852 into this one. So discharge equal to 370.59 into 10 power minus 6. Wow, actually so much lesser. Okay, because this we are just considering the meter cube per second. Okay, we'll just convert the entire thing into meter, and just at the end we can just convert. So if this meter cube per second means now 1 meter equal to 10 power 3 millimeter. So this is so how much will come? 10 power 9. Okay, so then q equal to 370 into 10 power 3 millimeter cube per second. Okay, we can just put a class multiplication. Root of 2 into this one is 7 into 1 7. 175 into gravity is taken in 10 to 10 power 3. Okay. So velocity equal to 591.60 millimeter per second. So area is given, so discharge equal to into of 200. This is the entire thing for the discharge equal to 11321 millimeter cube per second. So the next thing is about the volume. So volume is given 10 power 6 millimeter cube. Okay, then discharge equal to, it means since volume divided by time. Okay, so volume is given, discharge is given. Okay, time equal to volume is 10 power 6 divided by 118.821. So 10 power 6 divided by 118, literally 8 seconds, 8.45. So option B is the right one. Suppose if we also did in the meter also, definitely the answer will come, but why here? Maybe. So then this is the next one. It's been asked in 2007. 200 mm long screw, down screw of an area cross section. Okay, the area of cross section here is given, and the area of around the other end there is given. Okay, constant head of molten metal is maintained by the pouring down. Okay, constant head. Okay, of molten, constant. Q is constant. The metal for it is Q is given. Q equal to 6.5 into 10 power 5 millimeter per second. So consider the end of the down screw is open. This one is open. Here the pressure will be atmospheric pressure. So the area of down screw, they are asking this one. So okay, so continuation A1 B1 equal to of A2 of A2. Okay, so A1 we have just known. Okay, because Q equal to 6.5 into 10 power 5 equal to of A1 into of V1. By this we can just find the velocity of V1. It means upper velocity, because here the pouring compressor, since it has a little bit of height, you can just find it. So 6.5 into 10 power 5 equal to area on 650 mm square. So this is into V1. So how much will come? 6.5 into 10 power 5 will be 650. So 1010 10 power 4 equal to V1. So 65 into 10 power 3 divided by 65 V1. So 65, so 10 power V1 equal to 100 millimeter per second. So V1. So by this we can just it means so A1 V1 equal to of A2 V2. So we don't know V2, but we know A1 and V1. So we also don't know A2. So how we can just find the V2? So V2 equal to this 200 plus of this H. Okay, 2G of H. So this H is 200 mm plus of the pouring basin, that height. So H not. So how we can just find this at all? Because V1 equal to root of 2G of H. This one is pouring height. Okay, V1 we just found 100 mm per second. The whole square into divided by 2 into G is given 10 power 4 mm. Okay, into of H. 10 power 126 divided by 2 into 10 power 4. So 100 divided by 2, 50. So H equal to 50 mm. Okay, this one now we can ask V2 equal to root of 2 into 10 power 4 into 50 plus of 200. So how much? 250 mm. So find what is the value of V2. 2 into 10,000 into. So actually V2 is 2236. Okay, now we'll just calculate A2. So we research Q equal to 6.5 into 10 power 2236 mm. So this is around Q. So what is in here? So 6 into 10 power 5 2236 290. So you can see C is option. schematic diagram of pouring basin. Okay, each and everything is given. D2, D1 is given, and the depth of water material in the pouring basin is 100. The height of the okay. And so okay, this D1 and this D2. So continuity equation. So what is the continuity equation? A1 equal to of A2 of V2. So this pi by 4 D1 dot by into D2 pi by 4 D2 is also of V2. So D1 is D1 divided by D2 is also equal to V2 by V1. Okay. So since now we can just consider this V. So simple. So we will root of 2g of h. So this one is the side is root of 2 into 10 power 4 into 100. So next to V2 equal to root of 2g of h equal to root of 2 into 10 power 4 into 150 plus of 100 1600. Root 2 into 100 Padi Sami. V1 comes around root 2 into 10 into, so V1 is this one. V1 equal to 1.14 millimeter per second. V2 equal to root 2 into 10 into 1600. V2 equal to 5656.85 mm per second. Okay, now we want to just divide. So 56. So divided by 144. So what will be the answer? D1 by D2 equal to 2 is the answer. Four, okay, because this means square, okay. 5 1 2 So option D is the answer, but directly here 4 will come. A1 V1 equal to V2 V2. Oh, sorry guys. So this is okay. This is A2 of E1 equal to A1 of V2. Sir. So now definitely that is right. Just my mistake. So the next you can just see the next is this one. A screw of unknown top sand screw is given. So what is the top dia? Top dia is 20 mm and height is screw, okay, height is 200 mm. Velocity of water bottle, nothing empty of here, the velocity V1 equal to 0.5 meter per second. So definitely the pouring cup would have certain height. Possible gravity, if the mold is well ventilated, the velocity, because what is the velocity of V2? Simple, A1 V1 equal to A2 V2. So A1 just given, A1 is 200, diameter of pi by 4 d square. A2 V1 is 0.5 equal to what is A2? A2 we don't know A2. velocity, we don't know what is the value of V2 into V2. So V2, okay, just simple guys, V1 equal to root of 2g of h. By this we can calculate this height, and for V2 we can, this 200 is given, so V2 equal to 2 into 100 power 4 into this 200 plus of this calculated extra pouring cup, pouring basin height. That's it. Extra, this one also we need to consider. Okay, so I think so you can definitely use the answer will be 2 point something. So you can see here actually we can know what the pouring cup height is 12.75 mm and 12.75 mm plus of 200. So this one, so rightly we get the answer. So I think so you can just go for the next question. So this is also some of the most important thing that you want to also see, because this is called as gating ratio. So gating ratio is also defined as sprue area, runner sprue. Main thing is sprue area, runner area, and this is the inlet area. So I think so. So this is sprue area, this is runner area, this is inlet area. So sprue area, runner area, inlet area. Okay, all the three are most important thing. So you can see the gating ratio 1:2:2 means you can see here the sprue area is lesser, but runner area, the inlet area is a little bit higher. So you can see why the sprue area is a little bit lesser means you can see it is free from erosion and will minimize oxidation. So the sprue area is so much important. Sprue area is important for oxidation and will produce uniform flow. Okay, so next time is a gating ratio of 1:4:4. It means so sprue area is okay, but runner area and inlet area is so much lengther means they will also favor for oxidation. Okay, these things. Okay, things we can understand. So this one you can see is down sprue, runner, inlet. So sprue, runner, inlet. And this one you can see that get is some sprue, runner, inlet. Okay. This one you can see the rate of flow of metal through sprue is not a function of cross section area. No, this is completely wrong. Okay, this one also can proceed. So you can see here. Okay. Okay. So the next thing is riser. So these are the quite interesting things that you also want to see, because riser are added reservoir designed to feed liquid metal to solidification casting as a means of compensation for solidification. So just now for liquid sinking also, for solidification also we are just using riser. To prepare this, the riser must solidify after casting. Yes. To prepare the riser means, for example, the casting should be means become solid. Riser should become solid later on. So for riser design and for riser designs, riser and riser design according to Chevornier's law. Chevornier, Chevornier's law. Chevornier's rule. A good shape of the riser would be one that lasts long as switching. Riser should have long freezing time. Riser should have long freezing time. Okay. So this next thing is the riser, also known as hot reservoir, receives the lost hot metal that enters the mold and generally do so at the time when the metal in the mold cavity is already begun to grow and solidify. In a mold, a riser is designed and placed so that riser will solidify after casting after casting as solidification. A riser is a reference metal which will supply the metal where the shrinkage gravity would have been occurred. Okay. So Chernobyl law is this one. So total solidification time Ts. So total solidification time Ts equal to V into V divided by volume into area into N. Okay, you can see V is mold constant and is a function of mold material, casting material, and condition of the casting. So B is mold function of mold, which shape of mold you are using, mold material, casting process, casting material, and the condition of the casting. It means it depends on the surrounding environment condition of casting. So B depends. So I think you are getting the point. So n is generally 1.5 to 2. Okay, here is been n is generally 1.5 to 2. So the next thing you can see. So generally it means V by A. This ratio of ratio should be 1.25 times of V by A of the whole square of casting. So the square is so much important, guys. You don't forget, because the n value is 1.5 to 2. So generally we do take 2 and we do is everything. So that is the most important thing that I just request you to not to forget. Okay. So the next thing is area, means entire area, guys. This is the most important thing. For example, this is a circle. So cylinder means volume equal to pi by 4 d square into h. This is the volume. But for area means this covered area plus of this top area. Okay, this top area is pi by 4 d square, but this covered area is, this also we need to consider. Okay, so this entire covered area is 2 pi r into L. So this 2 pi you can just say it means pi by 4 d square plus of 2 pi 2 r we can write as pi d into L. L is the length, it means height. Okay, so the next thing is this thing. So you can see we are just considering it means one area, this or what about this one. So we need to multiply into 2. So the entire area is 2 pi by 4 d square plus of pi dl. Okay, so here each and everything we need to just consider, guys. Do not forget. So the next thing you can see, it means time equal to v by area the whole square. Here time is directly proportional to the volume and time is directly inversely proportional to the area. Okay, okay, so we can just see the first question. The relationship between the total freezing time T and the volume of casting V and the surface area is according to Newton's law is D, V by A the whole square. Okay, so now instead of seeing problems, we can just go for other theoretical comments. So by using some kind of videos, I just taking each and everything. Okay, next one is this one. This kind of thing comes in the category of special casting. So first one is shell molding. So I'll just show you a video. So later on you can just understand and you can have a clear cut understanding. So shell molding. Wait, I'll just share this in YouTube. So you can see this about shell molding casting animation. Okay, so I would like record to
today's session we learn about shell molding process. So it is a casting process in which the mold is thin shell made up of sand and which is held together by thermostatic resin builder. Here the process consists of following steps. The first step is to create pattern, and here pattern is a composed of two pieces which are created in shape of desired part. The next step is to create mold. During creating the mold, each pattern half is heated to 175 to 370 degrees Celsius and coated with lubricant to facilitate removal. Heated pattern is clamped to dump box which contain mixture of sand and resin blender. The dump box is inverted, allowing the sand resin mixture to coat the pattern. The heated pattern partially cures the mixture which now forms a shell around the pattern. Each pattern half and surrounding shell is cured to completion in oven, and then shell is ejected from the pattern. The next step is to assemble the shell mold. Here two shells are joined together and securely capped to form the complete shell mold. The shell mold is then placed in flask and supported by baking material. The next step is to pour the molten metal. During this step, the mold is securely clamped together. The molten metal fills the mold cavity. After mold has been filled, the molten metal is allowed to cool and solidify into the shape of final casting. After molten metal has cooled, the mold can be broken and casting removed. Here trimming and cleaning processes are required to remove any excess material. In shell molding process, the thickness of shell can be determined accurately by controlling the time that the
think so. For the point, for example, I'll just show the real animation video. Maybe investment casting, shell molding. So you can see here how this may be, I think so, but I'm not 100% sure. It's a investment casting. Okay guys, I think so. I'll just get started. You can see the shell molding, the sand is mixed with thermosetting resin and is allowed to come into contact with the heated metal pattern, because I think so at the pattern. So pattern it means just a pattern. So we will just heat the pattern, and the sand is mixed with the thermosetting resin. It means thermosetting resin, it means along with the sand. So this kind of sand. So now we will just make it to contact with the pattern. Now it means a sheet of 3.5 mm of sand and the plastic material added to the pattern. So then the shell is removed from the pattern. Okay. The next is the average shell thickness achieved depends on the temperature of the pattern as well as the time that the coated sand remains in contact with the heated pattern. Okay. So the next thing is, you can see the cope and drag and the shell are kept in the flask with the necessary backup material. Okay. The cope means each and everything as a proton can produce complex parts, a good surface finish and a good tolerance reduces. It means it has a good surface finish as well as a good tolerance which reduces the machining. The metals can be cast iron, aluminum and copper. So and the other thing is, you can see ferrous metal we can't just do, because as it's going to get heated so much, you can see 1536 degrees Celsius, it means the entire resin gets evaporated. Okay, so that's why this kind of metals, especially the ferrous metal, we can't generally go in place in the middle of this kind of casting material. Okay, so the metal is the molding sand is a mixture of fine grind quartz sand as well as a powdered bakelite. Okay, powdered bakelite. So what is this bakelite? Let us see. So bakelite is common. You can see bakelite is a common name for a bigger name. Okay, synthetic plastic. Okay, that's it. So okay. So cold coating and hard coating. Cold coating and hard coating are also used for coating the sand. Cold coating is quartz sand is poured into the mixture. Quartz sand is poured into the mixture, and then the solution of powdered bakelite in acetone and ethyl aldehyde are added. Mixture of 92% quartz sand and 5% bakelite and 3% ethanol. So just a normal thing. So it's like they also will heat, but so much heating won't be done. Okay, hard coating, the mixture is heated to 150 to 180 degrees Celsius. Where loading inside. In case of sand mixing, the soluble phenyl formaldehyde resin is added. Okay, so soluble phenyl formaldehyde. In that bakelite, acetone and ethyl aldehyde is been added. So you can see the mixture is allowed to cool up to 80 to 90 degrees Celsius. And hot coating gives better properties to the mixture than the cold coating. That's it. So you can see advantage, time and accuracy is good, and smoother surface finish. Oh, wow. Due to finer resin, because grain size should be so much lesser, so it can obtain smoother surface finish, and very thin section can be casted. Very thin sections can be casted. Very small amount of sand. It means sand is needed. Okay, but the limitation is expensive. Definitely is expensive. Small size casting on small size, highly complicated set can't be obtained. Most sophisticated because you need to turn, you need to distill. So most sophisticated equipment is needed for landing the shell molding applications. You can see cylinders and cylinder heads for air-cooled IC engines, automobile transmission valves and piston rings. We are just manufacturing by this. Okay, let us see some of the question. You can see low cost, definitely not. Easier, definitely not. Good surface is closer down. So 1 and 2. So you can see 1, 2, 4. So mostly 4 cannot be, because it's a little bit so much complicated. So 4, okay. So the next one is the ingredients used to molding. This molding is dry silica sand, definitely. So phenyl formamide, definitely. So 1 and 3, because sodium silicate we can't use. It will get so much water. So caustic also, clay also. So in shell molding, how the shell thickness is being controlled by maintaining the temperature and by controlling the time. By controlling the time during the pattern is in contact with the no. By controlling the time during which the pattern is heated. Pattern is heated? No. Pattern is heated, but by maintaining the temperature of the pattern in range of this. Okay. By controlling the time during which the pattern is in contact with the mold. Okay, then definitely he is the right one. Okay. So next one, shell molding can be used for producing. So let's see, very thin section can be casted, very thin section. So producing thin casting. Okay. Each of the following are applied in shell molding: resin binding, metal pattern, heat coating. So all of the three. Okay. So the mold in a shell molding process is made up of which? Mold gypsum setting with tight silicon, phenolic resin. Okay. That's it. So you can see in this green sand. Green sand is used in clay because it lies left of water. So coarse sand is maybe coarse sand is this organic. Okay. Next is shell molding. Shell molding is plastic. CO2 process is silicate. Okay. So this one is called investment casting. Okay, investment casting is also one of the most important things that you want to just look upon. Wait on the show. So you can see this one. Okay. So this is investment casting. So where will just also show you another video. So simple for with this one.
In today's session, we are going to learn figure shows investment casting process, which can be summarized in following steps. This casting process starts with production of wax patterns. Here, metallic dies are used to prepare wax patterns. An assembly of large number of wax patterns are made and attached to wax flue centrally. Then the pattern is immersed in refractory slurry, which completely surrounds it. This will cover or invest the assembly of wax pattern with the refractory slurry, which beats the shell and set this to room temperature to form the mold. Now the mold is further heated so that the wax pattern melts and flows out, leaving the required cavity behind. After heating process, the mold gets further hardened and molten metal is poured. Once the metal casting solidifies within the mold, the metal casting is removed by breaking the refractory mold, and gates and runners are cut from metal casting, and machining is performed to finish this metal casting dimensionally to get desired dimensional tolerances and surface finish.
Okay, I think so you can understand. So just a normal process. So first thing they will use it means wax. So investment casting process or last wax pattern. So produces expandable wax, use plastic and polyester pattern, assembly this pattern into gating system. So next one is investment or covering the pattern assembly with the refractory surface. Because next one is melting the pattern assembly to remove the pattern, firing the mold to remove the last trace of the pattern molding, and next pouring mold and knock it off and cut off. So you can see this thing is especially how they are just filling and how they are just doing, because I just told in the video you have to clear cut understanding. So next one is in the because next again ceramic shell investment, because in ceramic shell is built to around the tree repeatedly dipping a pattern into slurry and different material such as zircon with the binder. So after each dipping and stroking is completed, the assembly is allowed to thoroughly dry before the exploding of the thread. Okay. So advantage you can see dimensional tolerance, excellent surface finish. 1.23 nesting can be reduced to complete wow. Very high melting point, alloy can be cast. High melting point alloy can be any of metal. Allowed unlimited intricacy, so any shapes you can just do. Unlimited freedom the complexity, so most of the complexity in this you can apply. So you can see application aerospace and rocket components and gas turbine blades and surgical instrument. Replaced costly batteries are labor cost is high. Limited size. And next one you can see about this one. First one is the sequence is slurry coating, stockio coating, pattern mentor and shake coating. That's it. So next one, the expandable pattern is usually investment casting. Expandable pattern because it's wax. Expandable pattern, expandable is investment pattern. So investment casting is used for shapes which are based on complex pattern and scientific. So option C, shapes which are very complex and intricate can't be casted. So the most popular casting the gas is investment casting. Plastics, anti-wax. Okay. Investment casting is used for precision certainly. Yes. Light and indicate what is called investment. Okay. Oh guys, then the video is finished and let me see you in the next one. Until then, take care, have a good day, bye bye.